warm welcome to today's session. The first webinar this year from Smart Cabinet Building, from that initiative about paperless testing and commissioning with E3.WiringChechks. I would start with a short introduction update or introduction about the partnership between the three companies for Smart Cabinet Building: Weidmüller, Comax, Suken, and Armbruster Engineering, with the main focus, objective, building bundling and of competence and know-how for the today's and future challenges of cabinet building. At the end, I think that graphic shows really in detail what we will provide together with all the partners. At the end, solutions in the process chain around the digital twin, starting at the end in the engineering, of course, with E3 series. And then the full process about automation and digitalization of the manufacturing process, the wiring, and also testing and service department. And this is also the focus for today. We'll present with E3.WiringChechks a solution in that area for testing and service department. The history or the idea behind at the end, you can see on the right side an example of one of our customer, how they work today, or the early paper-based commissioning process. At the end, they have a lot of paper, print out each schematic and many other documents to have everything available, and then just to test the wiring, detect at the end also issues, and correct that also by the engineering, manufacturing, and then to at the end check it on the paper with a pen, mark it like this way, or just to do it with a checkbox. The challenge at the end, all the records has to be tracked, corrected by the engineering, and then of course if changes from the engineering will be released in I think changes are the daily business of every one of us. From that point of view, the changes has to be identified, and potential verification or re-verification must be displayed at the end. And also this is a really innovative example, I would say. Also really creative. I really like it, therefore I also have it here. It is this customer put the paper at the end into a plastic foil, and just mark the wires on that foil, and have in the background he has at the end the paper. If there is a new version available of that schematic sheet, then he just take out the sheet, put the new one in it, and he has stored at the end the status. At the end, as you can see, many I think many innovative solutions are already in place, but all at the end based on paper. And with E3.WiringChechks, we will transform that at the end to a digital way, to do everything digitally on a tablet or on a touch screen, and based on the E3 dataset. Here you can see an example how it looks like at the end. Then in E3, it's just mark the wires as corrected, or at the end also to detect issues on devices, to check also devices if they're okay, or if they have errors. Place then directly also the description text, which can be then also exported and sent back to the engineering. At the end with paper, it's always difficult. You have to scan at the end all the paper, or you can go to your colleague in the engineering department and put him all this paperwork on the table, and then he can work on paper per paper, and do the changes and at the end in the schematic. With that, it's also a digital way to send back the information to the engineering, and then he can also step by step work on each topic. It's also at the end to merge different test states or different versions together are supported, and of course finally also to have a report functionality to export at the end the event protocol or error protocol, where all the issues are listed in a PDF or in an Excel file at the end for post processes, or maybe also if there are some documents needed for some regulations, norm needs or whatever. Yeah. Just a few words on the slide. The main objective is to show that at the end live how it works in E3. For that we will jump to E3. I've opened the E3 Redliner. At the end, it's not needed to have a full version of E3 available. At the end, just to have with E3 Redliner reduced, let's say, functionality based, focused on the needed functionality, navigate at the end in the schematic, jump between also schematic and panel, of course, to have all information and to do at the end the wiring check itself. In general, without needing at the end wiring checks, there are many benefits which you have automatically if you use the E3 dataset, the native dataset. Of course, you can easily navigate at the end in the project. It's not to go through a printed schematic to all the sheets to find the right page, the right schematic sheet. You can also at the end open up the 3D panel, for example, can easily switch also to 3D itself. You have all the information in it. Also, it's not needed to have a bill of material or an additional bill of material, again, printed in Excel or whatever, a device list. Also, this information you have all at the end in the schematic and are easily available. Just click on it at the end, and then you can see also here on the right side at the end, it automatically shows the article number, for example, or the needed information. You can also add or configure it that it shows, for example, internal article numbers like an SAP number to have that then also related to the internal logistic workflow. Of course, you can also open up the device properties if you need more information. Then you have all the article information stored, available. I think every one of you who knows already E3, this is the big benefit anyway from E3, that all information are stored in one data set. You have everything available in one view. Of course, you can jump back, then also navigate between the schematic and the panel itself, and start, of course, now the commissioning process with E3 wiring checks. For that, we have two windows. One is the main window, let's say, where you can add at the end mainly work on it to check wires as marked as okay, or to add issues, to delete that if you did, for example, something wrong or a selection was not correct. And we have on the right side, we have the protocol, the event protocol, where you can see all the issues. Some of our customers also have in parallel to the paperwork, to the schematic, which is printed out and to use a pen to mark it. They have in addition also an Excel file where they track at the end also all the events, all the issues. With that, we have also that integrated and digital available to have a proper overview. We will start now with the test of one test object of a device under test. At the end, also one schematic can be related to more than one physical product. For example, you can produce with one schematic 100 cabinets or machines or trains, for example, and each machine is in a separate test state. We can create a new one, or we can choose an existing one. For example, I will choose now an existing one because I had already yesterday the whole day I did my tests, and I will continue on that test object. Then it's just open up the test state, and it imports at the end the full status. If I go through the schematic, you can see that there are already lines or connections tested, and I can easily now continue on that state where I've ended the day before. Good. At the end, it's easy to then to work with. Just select the wire at the end, and then click the button that it is tested. You can see it is if you go to the other side, then it is also marked on that side. Means it's not needed to if you work with paper to mark it on both sides and always to go to the other side. It's automatically at the end done. And of course, when we go back, if you click again, for example, you mark it, you see maybe, oh, I did something wrong, wrong selection, whatever, then you can also delete that, which is maybe also a little bit more complicated if you have it already marked on the paper. To make that, to make an undo on that, here you can easily delete, and then can work at the end or can correct the selection. I will go to this page here, where I've also a full path with a motor, for example, where I want to start to test. As I said, you can just select one wire. You can also, of course, you can also select more than one to have a bigger selection, and then just click the button, and then all wires will be marked. Or if you have, like you work on paper with a pen, and then just to go through the paper and do the tick box on each wire. Also this at the end is supported if you will do work much faster. Then it's just a double click at the end on the button, then it is allocated, it is locked, and then at the end it's just it's like with a pen, just to go through it at the end, to go through it and mark everything as okay, as you can see, and then to go back, just clicking once again the button. The last topic is also a selection of the object itself. For example, this device, if it is fully tested and all the wires are correct, then you can select wire by wire, or you just select the object itself, the device itself, the symbol, and then you click yes, it is tested, and then he will automatically mark all wires which are connected to that device as okay, and then you can easily also mark it in one step. So let's go back to that side, because I think it's not everything is green, means everything works fine. There maybe are also some issues which you have detected or which you find out at the end. Then just mark, for example, more than one wire, and we add an issue, we add an error. Then we have that dialog which helps the worker, the user, to describe at the end also more in detail. We have two rejection class, or let's say classification fields, one main, let's say main classification, and then also a subclass and main class here. For example, the wiring and missing wire, for example. There are some classification. You can fully configure that. These are just, let's say, examples. And as you can see, also if we change that assembly wrong, then the subclass will change. You have other values here available. But let's go back, wiring and missing wire. Then we can also define the responsibility, who is responsible for the issue and for the correction, also for the execution in a person, for example. In this case, it's the engineering department one. Typical German names, Franz, and you can also define the priority. Also, this is at the end fully configurable. It's not really urgent. It's enough if it is fixed then in 1 week. And you have some additional values which you can define. One important thing, for example, is also I have clarified with the engineering. Franz is already informed. He knows it. And then finally, of course, you can add also a description text. You can describe, you can write whatever you want. At the end, it doesn't make sense to write a book here. I think in few words that it is clear what is the issue and what should be changed. For example, wrong cable defined, and then just say OK. And then by clicking close to that wires, just clicking on the paper on the sheet, and then it plays automatically also at the end the description text, which is then, or which can be then also, as you can see also in the other issues which we have already, which you can send then back to the engineering, and the engineering can import that in the data set, in the engineering data set, and can easily correct that. The same thing is also working at the end with objects, with the devices itself. One thing, of course, in the schematic, but also in the cabinet view. In the 2D view, for example, of that mounting plate, just select at the end, select the object. For example, if you have some setting values, for example, the current which has to be defined, or also for a PLC device, for an I/O node where you have to add a PLC address, for example, to check it, then just select it and say yes, I have checked, it's correct. The address is we have the right address defined, for example, or you can also use this one. There is something wrong, maybe wrong article is in the cabinet placed. You can also jump back to the schematic. You have the information here in one click. You can check also in the schematic itself. For example, you can select this one or this one, this symbol, and then just add an issue, for example, hardware, whatever, and it is wrong article. You can describe it. And in this case, it's not an issue from the engineering, because the engineering has used or placed the right one. It is made, the mistake was made from the pre-assembly unit, for example, and in the Hans, and it has to be done, it is really urgent. It has to be done in the next 24 hours, corrected in the next 24 hours, and then just again click on it, place the text on it, and then you can also add issues which are related not only to the engineering, at the end for the whole, let's say, process chain of a cabinet, from manufacturing to the testing, the test field, the commissioning department. And maybe you have already seen that on the right side here in the protocol, it is automatically updates. All issues are listed at the end. Here I can easily edit, do some changes on that with a double click on it. I can, for example, change change the text or add some description, additional description text, article number XXX is the right one. Please use that. You can define more information. It is automatically updated then also on the paper in the sheet itself, and it is consistent between both views. What you also can do is, for example, to filter it or to search. You can search here for issues or for events. You can filter it, for example, the responsibility, if you will split it between where is pre-assembly unit responsible, if you are from the pre-assembly unit, or where is engineering in the lead to do something. There you are fully flexible in case of filtering, of course, also maybe in case of the name. If you are, for example, Hans, then you can just filter it and then go to your topics, and then you see, oh, these topics I have to correct. Green means it is already corrected, but it's still there, maybe also for training purposes, just to review at the end, also to which are, let's say, issues which normally happens. Maybe there is a know-how gap also in the team, and then maybe to train also on that level, to be more focused, to let's say also reduce the issues if some issues happen often. Yeah, what you can also do is this one here. You can jump at the end with a double click. You can jump directly to that issue, to the schematic, and we can see here this is already marked because, for example, the manufacturing had already corrected the issue. For example, it is already corrected. Engineering has updated in the schematic. The manufacturing has already corrected in the cabinet itself, and then he has marked, hey, I did it, and this is also at the end helpful information for the commissioning engineer itself, for the test engineer itself, that he knows now I can go to that topic and I can check it again to do again a verification if it is now okay. Good. It's easily also to navigate. Just click on an issue in the schematic, then you just see the filtered view. For example, if you have nothing selected, then you see the full view. And last but not least, you can do an export that to PDF or Excel file. And then, of course, you can use it for, let's say, needed documentation for special regulations, whatever, to use that for that it is, let's say, finally documented. Good. Yeah, let's go back to the slides at the end. As a short summary, I think easily and also to work in a digital way, to mark all the wires, to add issues, to have also for the issue definition, to have this classification, that it is more structured, and then at the end everything on a digital way. I think on the same level, like if you work with paper, of course you need the needed hardware, and with many benefits, of course, also compared to the paperwork itself. Some additional functionality which I will share with you just on the slide at the end. It is also possible that more than one person is working in parallel on the same project, on the same test object. For example, if you have a let's say a combination with testing, with manufacturing, that they are correcting that, testing has to test it, and then they work all on the same machine. Or with one customer in the railway business where more than one test engineer, commissioning engineer is doing the tests in the whole train, and they're synchronized between each user, that everyone has then the same test status. It can be easily done with one click, mouse click. The synchronization can be started, and then it's synchronized through the network or through a network drive between each user. Also, very important topic is the update, change, and merge mechanism at the end. Of course, you start with the version 1 of the schematic. Engineering has released the first version. You start produce it, then it goes to the commissioning department. They start testing, find out some issues. Then you start with an intensive change tracking process. Engineering is updating the new documents or release. The schematic itself will do a new release, version 2, and then there are some changes in it. And if you open up the new version, then just open up the project, define which test project you will work on it, and then it merges automatically together. It's analyzed the new schematic, what is in the test status, is the wire still the same? And in this example, we can see he will also write it into the message window that you can see, hey, these wires here were tested, but the engineering has changed from 2.5 to 4 square meter. And from that point of view, it has to be corrected. Somebody has to take out the wire, put the new one in it. Means it has to be verified again if everything is now again properly connected. Also, I think a very important topic, just to manage at the end the changes, or because I think changes are the daily business from all of us. Short outlook. Of course, we will continuously improving also the tools, also together at the end with your feedback. The main objective definitely is integrated change process between engineering and manufacturing, to combine that more, to have more an integrated process. Of course, also to enhance the graphic mode, to enhance the graphic mode with hand drawings, and also to make it more and more touch friendly at the end, and to enhance also the reporting. That's the let's say the main objective. Of course, together with you and with your feedback, we can continuously improve the functionality. Good. That's all from E3.WiringChechks. Just a quick overview about the functionality. Easy to use, fast to find, navigate, and then at the end also easily to mark the wires and to do the full verification. About the contact in that smart cabinet building partnership between Waldmüller, Kromax, Armbruster Engineering, Suken. Here are the main contacts. If you're interested, not only for E3.WiringChechks, also the full solution portfolio, which we will provide together with all the partners, then just get in contact with us. We are really happy to work together with you to improve your process, to automate and digitalize at the end the complete process. From our side, it's Achim Stirner, product manager for E3 series, and of course, also your already known local contact, Suken contact, is good to get in touch and to start a discussion about how to optimize, digitalize, automate your process. Short outlook about the webinars. We have, as Ursula mentioned at the beginning, every last Wednesday of the month, we have our webinar from our partnership. The next one is from Waldmüller about semi-automatic wire processing with the highly flexible wire processing center, 24th of February, then 31st of March from Armbruster Engineering about task-oriented design of industrial assembly workplaces and workflows. Let's check the homepage, smartcabinetbuilding.com. where you find additional information about the initiative. You can register in the same way like you did it for today, and I hope you will use the opportunity to also to see you next time in the webinar. Good, then it's already 30 minutes over. Let me check the questions. I think I cannot answer each question. I will definitely come back then after the webinar to every one of you who has had a question. I think we have done some tests with E3 Redline and E3.WiringChechks and have some quotes, for example, about jumpers, how to manage that. I think that's this would be definitely a separate topic to discuss. And the last one, which requirements, especially according to the component data or project data, are necessary? For example, must the panel be routed? That's a good question. The panel is not needed to be routed, but it's needed to have wires in the schematic. It's not needed to have a panel. It's enough to have just a schematic with the wires in it, not only the connection. Because the wire is at the end what we will test, what we will check. From that point of view, wires are definitely needed, and that's the only one. It's not needed to have panel, of course, for the automation, for the automated process. Then for the wire manufacturing, etc. It definitely makes sense, and I recommend to also to use the routing. But for wiring checks, it's not mandatory. Good. The time is running. I will come back to every one of you who had already asked some questions. Answer it then after the webinar. And for today, I'm at the end. Many thanks for your attention. I wish you a great day, great week, and stay healthy. And hopefully talk to you soon. Thanks.